Hello guys, welcome back to the channel. So in this video we're going to continue with our agentic RAG system. So in the last video we look at multiple step reasoning capabilities. In this video we're going to look at multiple step reasoning over multiple documents. So in the other videos in the series we have been using only a single document. So let's say that you have multiple documents that you want to perform a RAG architecture over. So how do you do that? And that's basically what we're going to be covering in this video. So let's get to it. So in this video we're going to look at a recap of the previous video. We're going to understand the architecture of work with multiple documents. You're going to download the extra document that you're going to be using for a RAG system. In this case, you're going to be using the long roller paper, the long LoRa paper. So it's about a bit mouthful. Okay, that's basically it. And then you're going to look at, we're going to update our utils.py file, which you created in the very first video. You're going to also go ahead and create the summarization tools over multiple documents. And then finally, you're going to look at the limitations of what you're going to implement. And I'll give you a bit of assignment of how to solve that limitations. Okay, so let's get to it. So in the last video, we looked at working with multiple step reasoning over a single document, right? So sometimes this can be really frustrating. Let's say I have multiple PDF documents that I want to perform RAG over. So basically I have to find a way of joining these documents, like kind of attaching this document together into one document, right? Because we have to bundle them up into one kind of like document, right? So this is really a limitation and it's really not a fun thing to do. So in this continuation of our agentic RAG series, we will dive into the use of multiple step reasoning capabilities we explored in the previous videos, but this time we'll do it across over multiple or collection of multiple documents. So here is the exciting part of all this. Imagine an intelligent agent that can sift through a treasure of trophies of information. You ask a question, the agent basically seamlessly directs you to the most relevant document that can be used to answer the question. And that's basically what multiple step reasoning over multiple documents is all about. Performing RAG architecture over multiple documents. So let's take a look at this architecture. So basically we have the user's question or the user's query. And then this query is passed to the agent runner, and we talked about the agent what kind of agent runner in the previous video, so you can check those out if you haven't already. So the user query gets passed to the agent runner, or which is a task orchestrator. So in the agent runner we have the agent state and in the agent memory. So the agent runner passes this information to schedules what needs to be done, and then passes that to the agent worker. The agent worker has access to tools and different LLMs. So basing on the user question, we need to pick a tool, right? So either pick the LoRa paper, which can be used to answer the user's question, or the long LoRa paper, which can be used to answer the user question. So depending on the question, the agent is directed us towards a tool which is most appropriate to answer that specific query. So in this case, let's start from the bottom right here. We have two main papers, the long LoRa paper and the LoRa paper. This is broken down into chunks, and then we create a vector store of this. So from this we create a tool. So we create two main tools, right? A summarization tool and a vector index, vector query tool, right? So so the agent worker will decide based on the query which of these tools is appropriate to answer the question. So these tools will be sent to the LLM, and the LLM can see, okay, I have this question and we have this bunch of tools. Which of these tools is appropriate to answering the user's question? So the LLM will now decide for us which tool to select. We'll have a selector, and we talked about selectors in the previous video. So the selector will select one of the tools to use basing on the user question and the papers that we have and the tools capabilities of these tools, right? So the LLM will now decide which tool can be used, and then from there we pick one of those tools and use it to answer the user's question. That's basically how it works. So good. So now once we have that, is just basically an overview of this architecture. Again, you can feel free to take a screenshot of this image. If you want the image, I can send it to you. You can feel free to use it. I don't have any issue with that. Okay, so let me know in case you guys want to access these images or that I use in the articles. Okay, so now that we have that, let's go over setting up our utils.py file. Okay, so in the last video, this is what we have so far. In the last video, we did this part right here. In this video, this is what we're doing, and I've just created a new file, Jupyter notebook, set up basically the basic environment imports, and also applying. We just import this library. So let's make sure I run all this, and make sure I have the right environment selected, right? So I run this and also run this as well. So once we have this done, now let's update our utils.py file. So to update this utils.py file, remember we created this utils.py file in the very beginning of the video. So this utils.py file can only be used to create tools. Whenever you call this function, you can pass in a bunch of data like a document, path file, whether verbose or not, and you're gonna go ahead and create for us a tool, right? So I just made some updates to this a bit to use things like asynchronous, and they just made some bit of updates to it. So you can find the updated code. I have the updated code right here in this article, and again you can find all the link to this on the GitHub repository. I'm also going to, sorry, on the in the description of the video. I'm also going to provide the GitHub repository for this so you can find this code. So I'm just going to copy this right here, this code right here. Again, this blog article, the link to it is in the description as well. So I'm going to go ahead, select everything in this file, and then replace it with what I've just copied. So I've just updated this file. So we're going to use it now right here inside of our code. So good. So once you have updated this file, we are good to go. So the first thing I want to go ahead and do, let's go ahead and create a summarization tool. So we're going to go ahead and create our summarization tools. So to create a summarization tool, what I'm going to go ahead and do is go back in here, and I'm going to go ahead, I'm going to import a couple of things. So I'm going to go ahead and say, I'm going to create a list of papers that we want. So papers is going to be equals to, and to download these papers, you can find these papers right here. I have the link to this paper, so which is a long roller paper, the long LoRa paper. I've already downloaded the LoRa paper which I've been using so far. I also added the long LoRa paper in here. Okay, so you can go ahead and I can keep the link to this in the description, and where you can download this long LoRa paper file, or you can just search for it yourself online. Okay, so once I have this right here, I'm going to go ahead and pass in those files. So I'm going to say dot/data dataset/LoRa. Okay, so this is a LoRa paper, and I'm also going to add the other one, which is dataset, and then the long LoRa efficient fine-tuning.pdf. So I'm going to import run that. So once I have that, I'm going to go ahead and import a couple of things. So I'm going to say from utils, I'm going to go ahead and import create underscore doc2. So this, let me get that spelling right. So import and then create doc2s, just like that. I'm also going to say from pathlib, I'm going to import path. Okay, good. So once I have those done, I'm just going to go ahead and run this. So good. So once I have those imports done, I'm going to go ahead and use those imports. So I'm going to say paper underscore to underscore tools underscore dict, and this is going to be a dictionary. It's going to be an empty Python dictionary for now. You're going to say for paper in papers, right? You're going to loop through, and you're going to get each of those parts. You're going to print this creating, and then you're going to say paper let's get 2, just like that. Okay, just like that. That's simple. I'm going to go ahead and create the 2. So I'm going to say path is going to be equals to path, and I'm going to pass in the paper right there, the paper paper string that we'll get back, and then which is just basically a path far to that paper. So vector underscore tool, and you're also going to go ahead and create a summarization summary underscore tool. Okay, and this is going to be await. You're going to await this because this function right here is in a synchronous function. This one right here is not this one at the bottom right here. This is the asynchronous function. That's why we're going to await it, and that's why we have this running right to support the synchronous. So await, we're going to say create a doc2, and we're going to go ahead and pass in. Basically, we have the doc name, and it's going to be equal to paper. Sorry, path. You're going to play the path. Sorry, going to be path. Let me get the spelling right. Path dot stem. Also going to providing the document file path, and this is going to be equals to the simply path, just like that. So okay, this is the name of the paper, which is just the path dot the name of the tool, which is maybe like the let's scroll up here. So be like something like LoRa tool summarization tool, LoRa vector query engine tool, something like that, right? So we pass in the name of the document as the stem of this path, and you also pass in the document path, which is the whole path right here, the whole path object. So once we have this, then we're going to go ahead and say paper to dict, and you're going to go ahead and add, and you're going to say path.stem is going to be equals to a list of the vector tool and the summary tool that we just created. So that's all I want to do. So let me run this. This is going to take a bit of time. So you can see it's creating for the LoRa paper, which is the first instance right here in our list, the first string rather. Okay, so let's give it a bit of time, and this can take a bit of time depending on your internet speed and all that, how fast your computer is as well. So let's give it a bit of time, and once this is done, we can move on to the other section. While this is done, we can actually go ahead and write the code for other functions that we want to do. So we can also go ahead and just print out the paper underscore to dict tool, and you can see what is inside once this function runs. Okay, so now once this is done, you can see we have all this inside of it, so you can see the things right here. Good. So we're going to create a list of initial underscore tools, and this is going to be equal to the following. So we're going to say we're going to list list comprehension, you're going to say for paper in papers for paper in papers. What I'm going to do, I will say for t in papers paper underscore to dict, and then finally we're going to go ahead and get that. So we're going to say path, passing in the paper right here, and then we're going to do .stem, just like that. Okay, so that's all we want to do. So once we have this, then I'm going to go ahead and print out the whatever we get back. So print initial tools, and let's see what we get back. So you can see that we have put all this inside of a flat Python list. That's all we have done. And you can also go ahead and check the length of this list. You can see how many tools we have so far. You can say initial paper, and then you run this, you can see you have 4. So you have 2 documents and you're having 4 tools, because each document has a vector tool, and also a summary tool, right? So that's why you have 4 documents. So in this case, if you have 20 papers, right, then you have 40 tools. If you have 100 papers, then you have times 2, right? And that would be 200 tools, right? That's a lot of tools, because each paper has 2 different tools, right? According to this diagram, you can see right here, right? Each has 2 tools. Okay, good. So in this case, I didn't actually show how many tools it has, but in this case, in the other diagrams, I showed how many tools it has. So just note it has each document to have 2 tools, a vector tool and also a summary tool. That's why we have 4 right here, despite having 2 papers. So good. So once you have done that, let's move on ahead to creating the agent worker. So I'm going to go ahead and just add in here documentation. Just say let's call this just agent worker. That's all we want to do, and then I run that cell. So to create the agent worker, let me just close the side panel right here. So to create the agent worker, I'm going to say from llamaindex.llms.openai. I'm going to go ahead and import open. Good. I'm going to go ahead and create the LLM. It's going to be equals to the OpenAI LLM. That's it. And I'm going to see the model, and I'm going to pass in the model name. We're going to use the GPT 3.5 turbo. So we're going to use the GPT 3.5 turbo right there. Good. So we run that to create that tool to create the LLM. Good. So once we have that created, now what we're going to go ahead and do is create the agent worker. So we say from llamaindex.core.agent, I'm going to go ahead and import the function calling agent. I'm also going to say from llamaindex.core.agent, I'm going to go ahead and import agent runner. That's it. So we have the agent function calling agent worker, and you also have the agent runner imported. So I'm going to say agent underscore worker is going to be equals to function calling agent worker, and you're going to go ahead and pass in the initial tools. You're going to go ahead and pass in the LLM as the LLM that we just created, and you're also going ahead and passing in the verbose, and you're going to say verbose is going to be equals to true. That's it. So once we have that done, I'm going to go down here and simply say agent is going to be equals to the agent runner that we have, and you're going to use the agent worker, passing the agent worker to this agent runner. So that's it. So once we have this, I'm going to go ahead and run this. And okay, we have an issue right here. Agent worker missing one required positional argument, prefix messages. So let's go ahead and see what we are missing right here. Okay, we're going to say, sorry, my bad, you say dot from underscore tools. We need to use this method for this to work. Okay, good. So once that's run, you're going to go ahead and ask it a bunch of questions. You'll say response is going to be equals to the agent underscore query. I'm going to go ask a query right here. So we're going to say explain to me what is the LoRa and why it's being used. Okay, that's one question. You're also going to pass in another one right here. You're going to ask it explain to me what is long LoRa. Long LoRa. Okay, long LoRa and why it's being used. And you're going to ask the last question, compare and contrast long LoRa and LoRa. Okay, so that's the 3 questions that we have. So once we have those set up, you're going to go ahead and simply ask it. Okay, my bad there. So let me just go ahead and simply say print a string version of the response that we get back from here. So the responses, and let's run this. So we ask it 3 different questions. One question requires it to use the LoRa tool. Another question is ask it either the LoRa summarization tool or the LoRa vector tool. Another question requires it to use the long LoRa tool, either the long LoRa summarization tool or the vector tool. Then another one ask you must use both. So let's see what it does. So the first question right here, explain what is LoRa, blah blah, and as you can see, it's calling the LoRa summarization tool. Perfect. The second question, it is let's see right here, long LoRa. Okay, answering that question. Another one is, you can see, is using the LoRa paper for the other question. Perfect. And it's using the LoRa summarization tool, because a summarization can give us a whole overview of what is LoRa, right, and what is long LoRa. So it's using the summarization tools right there. And you can see right here, have the last question, which is just compare and contrast the two. And you can see the answer output right here. So you can see the output right here. That's perfect. Awesome. So good. So once we have this, can you also use the markdown display? I think from Python we can employ display and then display the final output if you want to, right? So yeah, you can actually copy this and then display the final output if you want to, right? Good. So once you have all that done, good, you can see how that basically works. So it's using all the different tools and doing multiple papers. So the agent LM is deciding which tool to use depending on the user question. So if it's a LoRa paper, it's going to use the LoRa tool, and whether to use if this use a LoRa tool, it's going to decide whether to use the LoRa summarization tool or the LoRa vector tool, right? So that's a bunch of choices that LLM is making right there. Good. So that's basically it, how you can implement an agentic RAG over multiple documents. You can have many documents as much as you want, and that leads to an issue, and that's what the next slide here should explain to you what the issue is. So let's say that we have 100 papers, right? So right now we have 2 papers and we're having 4 different tools. So all these tools are being passed to the LLM, and the LLM is able to select which tool to use. So if you have 100 papers, you're going to have 200 tools. So all that 200 tools is being passed to the LLM. Okay, that's you might think that's not an issue, but that's an issue, because if this tool description actually can be huge amount of text, right? So if you're having too many of these documents, right? Let's say you have 1,000 documents. So you're going to have 2,000 tools, right? That's crazy. And passing all that into the context window, few things can happen. Context window can overflow. So you might be thinking, that's not an issue anymore. We have models with 100, I think 1 million token context window. So that should be fine. Okay, that you might be fine. But the LM can get confused. So there are so many tools that you have to imagine that you have to make a decision out of 2,000 tools, right? That can be confusing. So the LM can get confused, right? And also one issue is that it's also expensive, because the more tokens you're using for your calls, more tokens you're using in your API calls to these models, the more you're paying, right? So it can be very expensive. The context window can overflow in case you're using a smaller model, and the LM can get confused in case you are finding context window, you're using a bigger model. The LM can still get confused and make the wrong decision in selecting the tool, and then you're finally gonna get a wrong output, right? So those are the limitations of this. So what's the solution to this? So you might one of the solutions is simply, we have something called tool retrievers. So basically you're performing RAG, right? But you're passing all the tools, the LLM, and the LLM is selecting a tool. So you're passing all that information into the context window. What if you're able to perform kind of a semantic search over the tools, kind of performing a RAG over the tools, and then from performing the RAG over the tools, we'll select only a few number of tools to send to the LLM, and the LLM picks from those selected amount of tools, instead of passing all tools to the LLM. And that's where tool retrieval comes into play. So basically you perform RAG over the tools, right? Each tools have a description, right? So each of these tools have a description. If I go in here, you can see the tools have descriptions right here. So you can see here, this will be the LoRa summarization paper, blah blah summarization vector tool. So you can see all this description. You can perform RAG over all of them and select the tools which are appropriate or close to answering this question, and then send only those selected few tools to the LLM. So let's say that out of 100 tools, we pick only 40 tools that are semantically close to what you're trying to answer. And those tools get sent to the LLM. From the LLM can make a decision. So basically, we are reducing cost. We are reducing amount of tokens you're using. So we also not overflowing our context window, because we're using only a few selected tools to perform our actions. So that's basically what a tool retriever does, performing RAG over the tools to select the most appropriate tools that can be used to answer the question, and then sending those appropriate tools to the LLM. And then from there, the LLM now uses its abilities to select the most appropriate tool based on the user's query to answer the user question, right? So that's basically how a tool retriever works. So in this case, I want to really give you a simple exercise to go over. So I told you I also write articles about this, and the article is right here on Medium. And here we have the advanced multiple document more advanced multi-document agentic RAG pipeline, and I explain all that, how to do all that. Okay, so I encourage you to go ahead and read this and see how you can create a tool retriever. And then from creating this tool retriever, you can use the tool retriever. It's quite very simple. So I just want you to go ahead and do this on your own. I'm going to put this link in the description, the link to this article in the description. Go ahead, read the article and implement it. And after that, you can understand how it all works. It's actually very, very simple. And I've gone over a lot of information and a lot of the details that can enable you to do this quite easily. The link to this article again is in the description of the video. Good. So that's a little assignment you can work on at the end of the series. So you can, if you enjoy this series so far and you have learned a lot about agentic RAG systems, and you want to connect with me, have an idea of projects you're running into issues, any recommendations, any referrals, any kind of, just want to talk to me, build different projects, you can reach out to me on Medium at Prince Cramper, where this article is. You can find me on YouTube at codewithprince, where this video is actually being published, hopefully. You can find me on X, aka Twitter, at prince_cramper, or you can connect with me on LinkedIn at Prince Cramper. Okay, so that's basically it. And I also want to get project suggestions from you. So that you have learned about agentic RAG systems, what are you guys aiming to build? What project would you guys want me to build? So let me know in the comment section below. Any project suggestions, let me know, and then we'll see how we can go ahead and building it, okay, using agentic RAG systems. And then we can attach this project to the end of the series to actually close up this series all in all. Okay, so thank you guys so much for watching, and if you enjoyed these videos, make sure you like the video. It's the easiest you can support the channel: liking the video, sharing this video with all your friends, family, and anyone who might find the videos interesting. And also you can follow me on other social media links as suggested. If you want me to support me further, you can buy me coffee. The link to that is in the description of the video below. Thank you guys for watching so much. Let me know what you think of the series, any project suggestions, all in the comment section. I'll do my best to get back to you. Thank you guys so much, and see you in the next one. Keep safe.